This will be our second presentation on structured text. So we're into the third language now, supported by RSLogix, Studio5000, the Logix engine. Ladder logic diagrams, function block diagrams, structured text, and sequential function charts, which we have yet to do, but we will do. So this is the second of the structured text discussions, and it's more about programming with structured text than language itself. Let's get at this. In this next section of the lab entitled Languages of the Logix Engine, and there are 4 languages: ladder logic diagrams, structured text, function block diagrams, and sequential function charts. In this next section, we're going to go over structured text. Now remember, we've already done ladder logic diagrams. In that, we created an application with ladder logic diagrams. Actually, we did it several ways. If you remember that we edited the logic to make it look a little different and to behave slightly different. In your actual lab project, you didn't actually create all of these routines. But normally in the classroom, when I go over a lab, it's more of a lecture than just a discussion specific to the exact steps in the lab. So I always try to include more in the lab wrap-up or the lab lecture discussion. When we left it, we had these 5 routines. We had 2 for function block diagram. We had this one, and then we modified this one. Remember that the timer timing LED did not display unless you had the display enable switch. Actually, you didn't get the start LED or the timer timing unless you had the display enable switch to enable this output. Then we created another routine. We eliminated that, and this actually behaves the same as this ladder logic. Next, we're going to add a structured text routine. Step 1 of your labs sequence, I had you open RSLogix 5000. When I did this, I called it function block diagrams. And you can see up here in the title block, it's slightly out of your view. I'll drop it down. See, function block diagrams. I didn't want to waste my viewing space on the title bar, so I kind of stretched it up and out of your view. And we want to be offline, by the way. You see I'm offline here. Now you could do this online, but it's much quicker if you do it offline and then download. So I'm going to stretch this back over here a little bit so you can see this whole display of text. I'm going to go to main program, right click, new routine, and ordinarily this would have been left in the last choice that we made. So the last structure that we created, I think, was a ladder logic diagram. I've actually been in here playing, so it came up structured text without me changing it. However, in your lab, it probably came up function block diagrams. We're going to have to change the type. So I'll name it ST01, structured text. Let's put an underscore in there. Make sure that you select structured text. Okay. And then we're going to go to, I had you go to the main routine and had you add another JSR rung. And I also had you add some logic to automatically deselect all the other choices if you picked one. So here we see that right now ST01 is selected. So I've taken the liberty of adding in this rung already. When we left, we only went as far as enable function block diagram _02. I added this rung. I also went back and added all of these unlatched bits. So no matter which one I select, I'm not online, so it's not going to really work right. Let's save this until we're online and I'll demonstrate this for you. But remember, the idea here is if I toggle on enable ladder logic diagram _01, I'm going to be jumping to this subroutine. And in case any of these others are also turned on, we have a one-shot here that unlatches those other bits. Now remember that a latch instruction, OTL, has a true-only execution, no false execution. And a OTU, or what you would call the unlatch instruction, it has also only a true execution, no false execution. The OTL sets the bit to 1, and the OTU sets it back to 0. If we were to turn on one of these bits, any one of these bits, and then turn on a different one, the one shot would unlatch all the other bits. This just saves you the trouble of toggling on and toggling off before you toggle on a new routine. We'll demonstrate that once we go online. I did have a question in the lab. It says, give your opinion as to why we made this modification to the logic. Well, we did it for convenience. It was literally a single action to turn on a different subroutine. We just toggle on the bit, and if there's any other selected, it unlatches those or sets them back to 0 when it turns on the one that you actually want to work with. Then I had you open the routine ST01. Now, I didn't have an underscore probably in the lab manual. It really doesn't matter what you name this routine. I try to pick something that makes sense. Sometimes I put in an underscore, sometimes I don't. The underscore makes it a little bit more palatable or readable, so I normally try to put the underscore in there. But you know, I created this lab maybe 6, 7, 8 months ago, and I'm just now getting around to finalizing it and recording the video for it. In that length of time, I could have done, you know, hundreds of hours of programming for some company on a project. And of course, when you step into another company's project to help them out, you have to adapt or adopt their standards. So maybe they didn't use underscores. Maybe they use strictly lowercase, uppercase as delimiters to make it readable. In other words, this would be S, capital S, lower t, 0, 1. So the lowercase t kind of takes the place of the underscore to give you kind of a visual delimiter between ST and 0, 1. Anyway, enough time wasted on that. So I had you open ST01, double click on it. I think I'm going to close all the routines and open up just ST01. Clicking on this X that was up here closes all the routines rather than right click and close them one at a time. And now I'll open up ST01 by itself. Now, structured text is quite a bit different than doing ladder logic. In ladder logic, certain things are implied in the iconic nature of ladder logic diagrams. There's a lot of functions that you don't have to pay attention to in ladder logic diagrams that you definitely have to pay attention to in structured text. Let's start adding some code. We're going to start in the upper left-hand corner, and we're going to add a construct. Constructs are things that are used to trigger structured text code other than statements. A construct is always terminated with a semicolon, but you can't right-click and select constructs. If we right-click, we can browse for tags, we can add a structured text element, but we cannot add constructs. So we'll start out by typing in uppercase IF. It's always good to use uppercase for constructs and then use lowercase or upper and lowercase for your tags. It just makes the code more readable. I could put in a space, but it's unnecessary. Shift, open parentheses. At this point, I had you right-click and then browse for a tag. Now, by now, you should have done enough ladder logic diagram, worked enough with the tag database that this should be familiar with you. However, just in case somebody popped in to this lecture without doing the dozens of previous labs and lectures, this particular tag database does not have that many tags, but in the real world, you might have 500-600 tags in your tag database, and going from the top and scrolling all the way down to find the one that you want is unthinkable. However, if you type in the first couple characters of the tag name, in this case we're going for an input bit, a bit that belongs to an input data type, and for the compact logics and for most control logics, applications, it's going to be local, meaning that the I/O card is in the local chassis. So we'll type in LO just to get us that far to local, then drop down the list. You see we skipped everything above the scroll bar here. See, it got us right down into the local tags. And this is an input. It's in slot 2, so we want to go to local to I for input, data. And you see the first 3 bits are grayed out and it says used. If you go to the 4th bit, bit 3, says unused. Now these are used in these routines over here. And remember that we are approaching structure text, function block diagrams, and sequential function charts by comparing it to a ladder logic program, ladder logic diagram that you're used to working with. Now, if you're a text-style code writer stepping in here, the ladder logic diagrams is irrelevant. But for most people using this as a training program, a training platform, they probably have a lot of ladder logic diagram under their belt. So first you create ladder logic diagram that is real simple and easy to understand, and then you duplicate it in these other languages. So in these other routines, particularly ladder logic diagram 3 and function block diagram 2, these two behave identically. Now we're going to do a structured text that behaves identical to these two. So we're going to go ahead and pick bit 0, even though it's already using these other routines. Remember, we're only activating or enabling one routine at a time, so it's not going to make much difference. Now, in the lab, I made some mistakes and then left them in there to show you the error page pop up and how to correct them. One of them was I left off the bit. So if I had just picked this word right there, see, data, no, there's no decimal point 0, that would be an error. And an if construct is looking really for a Boolean tag. But we won't make the mistake. Now we're going to close the parentheses. If you have an open parentheses, you have to have a closed parentheses. Those of you that have done a lot of algebraic expression or other structured text languages know that if you open up 3 parentheses somewhere in the expression, in the construct, you have to close all 3 parentheses. So we opened a parentheses, now we close it. Then I'll put in a space just to make it more readable, then type in THEN. Far we have now, if local to idata 0 is true, meaning on, then now we have to type in something that we want done. So now we'll go get another tag. Now you see how that turned red as soon as I left this line? That means it does recognize it as a tag. If it stayed black, that would be a good indication that that tag is undefined. Anyway, right click, and we want an output this time, so we go to Browse Tags, we do the local thing again. Only this time we want an output, which is in slot 1, local 1, O for output, data, bit 0. Now we want to set this to 1. And the proper syntax is after the tag, colon, not semicolon, but colon equal 1. And then a semicolon to complete the text. I'm going to hit enter again and then add END_IF. And then, of course, after that, we need a semicolon to complete it. So this should complete our basic little piece of logic. So this logic says, if this is true, and if we wanted, really, if this is on, then turn this on. If we wanted this to be equivalent to an examine off instead of examine on, or rather true if off, then we would say if not instead of if. So if by itself implies that the Boolean tag is on. So let's verify. You've done this many times before. 0 errors. Warnings we don't care about. Those are usually destructive bit because it sees You see here, destructive bit, reference detected, ladder logic diagram 3, 1, 1, 2, 2, function block diagram 1 and 2. These, and it's not even really referring to what we just did. It's referring to warnings about these routines over here. This is going to pop up whether you like it or not. We just close it down to get rid of it. The important thing was 0 errors. Now we go to Who Active, select the processor, select download. This takes a few minutes. Download again. I am using 38.4 RS232, which is considerably slower than 100 meg Ethernet. I have my Ethernet NIC on my laptop tied up doing something else right now, so today I'm using RS232 at 38.4K. And I will go back and clip out some of the delay. So when you listen to this, the delay won't seem that long, but believe me, it was long. Done downloading, change controller back to remote run, yes. Okay, we know we're in remote run because this bar right here is green. And down here is our watch window, and there's your output tag and your input tag. The reason the output is first and the input is second is because alphanumeric order. 1 comes before 2. If you watch this value right here, when I push the button, just for grins, let's go to the main routine, and let's select, let's toggle this one off. Now none of them are selected, so we're not running any routines right now. Go back to structure text 1, and I'm going to push the push button, or I could use the toggle switch. In my little hardware trainer here, I have momentary contact push buttons wired in parallel with toggle switches. That way, if I want to maintain contact, I have one. If I want a momentary, I have one. So I'm going to push the button, and you notice that local 2i data 0 is now 1. If I let go, it's 0. But you do not see the value for the output bit changing because we're not executing that subroutine. So we go back to the main routine. We can do that by clicking here. Now, I can right-click here and toggle on, but I can do that anywhere that I see the bit. So if I go all the way up to the top here, if I go to this instruction and right-click, toggle bit, it toggles it on. You don't have to toggle it on at the true if on. You can toggle it on anywhere that you see that bit. That does not seem to follow conventional wisdom, but remember that what you're looking at is an offline project animated by online data. Remember, there is no such thing as an online project. You can be online with your offline project, meaning you open up the project offline, because ladder logic, function block diagrams, structured text, and sequential function charts do not exist in the controller. Now the controller knows what language that they were written in, but by time all of this gets down to the controller, it's machine level language. It's none of these 4 languages we're working with. Always try to keep that in mind, that you're working with an offline project. In other words, all this graphics here, whether we're in structured text or in ladder logic diagram, it's just something for you to look at. Matter of fact, you don't really see any action here when the program's running. You have to actually watch the tag values. And of course, we can do that just by going to controller tags and then go down to local, we'll do the input one. And if you look right here, well, it looks like we have a switch on. I'll turn it off. Okay, so if I push that push button, see, bit 0 goes on. So this little view down here is just a little nice little feature, so you can look at your structured text and the values. It's not like ladder logic diagrams where you can see both at the same time. So this text right here is really not animated to the degree that the ladder logic diagram is. The ladder logic diagram is iconic in nature and is viewed iconically. Now we have our output turned on, and let's go back to our main routine and see what we are. We have structured text 1 running, and because, and you learned this in your in the training manual, in the lab project book, that this is the behavior that we expected. Now I'm going to toggle this off and do it again. Okay, so I'm going to push the push button. So the input goes on and the output went on instantaneously. Keeping in mind that in there I let off of the push button, and you see it went back to 0, but the output did not. The light is still on. That's because of the nature of structured text versus ladder logic diagram. I just wanted to throw in a point that the refresh rate of the screen is nowhere near the response time of the controller. So when the controller sees that the input bit is high, it's going to turn on the output within 1 scan, and 1 scan is probably well less than 1 millisecond. So if you look close at the screen when you did this, you did see a slight delay between the value of the input and the value of the output, but it is slow, slight, and hardly discernible. Not like when you're actually pushing the push button and seeing the light come on your demo. But this is how you would be troubleshooting if you were using structured text in an actual process. You wouldn't be looking at the process necessarily. You would probably be monitoring the data online like we're doing. Okay, now in the lab, we pointed out that although this looks equivalent to a true if on, energize output, rung, it's not. This says if this bit is on, then turn on that bit. But it doesn't say anything about if this bit is off. Whereas in ladder logic, an OTE has a false and a true execution. If the rung is true, it turns something on. If the rung is false, it turns it off. You don't have that luxury with structured text. And so you will see that this type of code is probably not something you would do with structured text. If you needed structured text for math functions or other complex scripting, you would put them in a separate routine, but all the basic stuff you would still do in ladder logic diagram. So let's add some more code here. First, I'm going to start pending routine edits. It takes a second to respond. Then we'll put the cursor there, hit enter, and we will do else. Do another carriage return or enter. Carriage return came from the days of typewriters when you want to start a new line. There was a big chrome-plated lever that stuck out from the carriage, and you push that, it released the dog, and you slid the carriage all the way across and started typing again. I realize most of you watching this have probably never used a typewriter in your life. Then, with electric typewriters, the carriage return was a button, of course, and it was still mechanical, the actual function, but it was triggered and operated electrically. And then, of course, along came computers and keyboards, and now the key says enter. It does not say carriage return because the key serves 2 purposes. It is an indication to your software that you're finished with whatever you were doing, or you want to start a new line in a word processor. Enough on that. Let's add in another tag, and in this case we're going to use the same tag, but we're going to set it to 0. So I'm going to drag my cursor through, do Control-C, put my cursor down here. First I'm going to do a tab, then a Control-V. I'm going to go back up here and do a tab there as well. This makes it a little bit more readable. Now this time I want it to set it to 0. So now it reads, if this bit is on, then turn this bit on. Otherwise, or else, turn that bit off. So let's verify, finalize. And we're back in the run mode. Now I look over and I see that the light is off. We'll get rid of our error window down here. We'll turn the watch window back on. Now when I push the push button, you'll see the bottom one go on first and then the top one next. But you're going to have to watch fast. You can barely see it. I can see the difference. Sometimes I can't. It just depends on the state of the video driver card when this takes place. We don't care about that anyway. We just want to see that this logic works the same as a rung of ladder logic. So the equivalent rung of ladder logic to this structured text is a rung with a true if off instruction and an OTE. Now you call it an XIC and an OTE. The XIC, or the true if on, addresses local 2i data bit 0. The OTE references or addresses local 1 O data 0. So this is equivalent to a 2-instruction ladder logic rung. In the manual there were several questions. In step 26 it says open routine ST01. Were there any outputs on when you downloaded the project? Well, there's always the possibility that there were. We call that data table carnage. If you're running one program and then switch to another, you may unintentionally leave bits on. So you should have turned them all off by toggling them off or making sure they were off before you left the previous piece of logic you were working on. So there could have been bits already on. But let's assume that there weren't. Flip the input on. Did any lights turn on? Of course they did. Bit 0 LED turned on. Flip the input off. Did the light turn off? Of course it didn't. We already went over that. And the reason why we explained a little earlier, and that is an if-then does not include an else. An if-then is a true execution, but there's no false execution. So then I had you download the code and test it, which we already did. And now you want to save and go offline with your project. Now I'm going to click on the little floppy disk symbol. It's interesting that this symbol has never been changed, even though very few people have floppy disk drives anymore. It used to be that one came with your laptop and just sat around and collected dust. And only on rare occasions. People use jump drives now, thumb drives, and external hard drives, and they just don't use floppy disk. But click on it to save. I think it's a good idea to always upload tag values before saving the project. Now, we don't have to do that because there is no data that we want to save. So just to save time, I'll say no. Then go offline. Now, there's two places you can go offline. You can click here, you can select go offline, or under communications. Doesn't matter which. Now that we're offline, let's delete this code. And now we're going to enter more complex code. And the code that we just deleted, that was just to show you what a simple rung of logic would look like if it was completed in structured text. Now we're going to actually do the structured text that matches the behavior of function block diagram 2 and ladder logic diagram 3, I believe it was. In this case now, we're not doing a construct. So we could right click, add structured text element, and go to timer counter and put in a TONR, timer on delay with reset. Now this, and you see we're left with an open parentheses, which means that we have to, in order to create an instance that we can address with a TONR, timer on delay with reset, within those open parentheses, we have to put a tag. Now, the tag that we used in the ladder logic diagram was a timer data type, but you can't do that in structured text. You have to use an FBD, function block diagram timer data type. So we'll put the cursor inside of those open parentheses, and we'll type in latch delay 2, because we want to leave latch delay alone, because that was the timer data type used in those other routines, the ladder logic diagram routines. Now, I may have already created this tag. We'll see. So I'm going to click outside of it, do a semicolon, and hit enter. Well, you see, that's still black. It's an undefined tag. And this is the way it should behave when you did your lab, because you would not have already had latch delay 2 defined. So we right click, just like you would in ladder logic or function block diagram or sequential function charts. New. Notice it comes up function block diagram timer data type, which is different than a regular timer data type. If you try to use a regular timer data type here, it just won't work out for you. Create. Now see it's red. So we create a new line. You could type in latch delay 2.pre. We'll do that. Colon equals, I'm just going to use 2000 semicolon. Notice that when I hit enter, even though I typed that in all lowercase, the only thing that didn't come up the way you would expect would be the PRE. So if you don't like the looks, well, don't worry about it. It knows what tag it is. You could go back and type in PRE if you like the way that looks better. Remember, this is just text. Now we'll right click, browse tags. We'll type in L. There's latch delay. There's latch delay 2. And this time we want enable in. Now, enable in is not part of the data structure of a timer data type. See, timer data type, function block timer data type. So we'll select that, and we want to set that equal to 1, colon, equal 1, semicolon, enter. And then we want to do timer enable as well. You can always select some of this stuff with your cursor, copy paste and all that. I find it just as easy to right click, browse tags, type in LA, expand latch 2, and I wanted timer enable. Double click, space, colon, equals. And then we have another tag that we want to put in. Browse tags, ST. That's close enough to get us in the ballpark. Start push button. Double click, semicolon, enter. And we're going to create a new tag here, accumulate. This isn't totally necessary, but this makes it easier to watch the value. Colon equals, and we're going to put in another tag here. Latch delay 2, expand it, go down and grab the accumulate. And then a semicolon after that. And put in a couple lines. What we've done here is 5 things. First, we instantiate a timer instruction, function block timer instruction, with the backing tag latch delay 2. Then we assign some value for the preset member of that timer function block diagram timer data type. In this case, in the lab, I think I had you use 1000. Well, actually, it shows 10,000, which is 10 seconds. And then later on, it says 1000, which is 1 second. It wouldn't matter what you use. It's still going to function. You just have to wait longer to see the light come on. I use 2 seconds, which is makes it a little bit more palatable because it gives you some time to look things over while the timer is accumulating. So we enable the instruction to function, and then set the timer enable member to function with the start push button. This would be the same as a true-if-on start push button and then adding a TON instruction. And then, of course, the last line, the accumulate equals latch delay 2 accumulate, that's strictly for display purposes in the watch window. I took the liberty of adding the next piece of code. Now, it's not the next piece of code that you added. You had a construct in there that said if start push button, then latch delay 2 dot timer enable equals 1, else latch delay 2 timer enable equals 0, end if. I left that out because that is redundant to this line right here in this block of code. The fourth one down, the latch delay 2 timer enable equals the state of the start push button. We didn't need that additional construct in there that said if start push button, then turn on the timer enable, and if not, then turn it off. That was redundant. Now you can do this many different ways. So you could leave it the way that it was in the manual and then delete the fourth line here. It would become redundant or unnecessary. So I added in the third piece of code. I also used some indentation to make it a little bit more readable. So you can see that there's a instruction and it's instantiated. Then you see your construct, if, then, else, and if. The third was to control the timer timing LED. This controls the start LED. So we're going to, and by the way, we're in the edit mode online. So I'm going to grab this code. See, there's a little delay that's very annoying when you're working with structured text RS-232-38.4. Works much faster, much cleaner with Ethernet. So Control C, come down here, Control V. In this case, it's going to be the timer timing bit. So we'll select that and then do a right click, browse tags, go down to latch delay 2, get the timer timing bit. Now there's other ways you could have done that. You could have deleted that tag that was in there, display enable switch. You could have deleted that and then typed in LAT, or the first couple characters, drilled down and grabbed it quicker. Only in this case, if we have the start push button pressed and the timer's timing, then we want to manipulate the bit that's associated with the timer timing LED. Again, we can verify that. It's not necessary. See, 0 errors. We know that those tags are good. And then finalize. Close our error window. Open up our watch window. And bring it up so we can see. Now push the start push button. And you see the timer timing bit was on. We'll do that again. Timer timing. At the end of 2 seconds it goes off. We still have the timer enabled because we're still holding down the button. We still have the start LED because the start LED is hooked to the start push button. So we started it. The timer timing LED only stays lit during the first 2 seconds. Now let's add in another little piece of code. Notice that these are all if, then, else, and if. Some of them have an and, a Boolean and some have a Boolean or. So we have 2 and constructs here. Let's add another one. Let's put it in the edit mode first by clicking on this button. We still have, yes we do, we still had that piece of code in our clipboard. This one is going to be if latch delay 2 done. Done bit. In our logical operator, we want an or, not an and, or latched LED. We'll just type that in. And then we want to add another logical operator, and not, open parentheses, right click, browse tags, type in RE for reset button. There it is right there. Let's finalize this. I cheated a little bit. I typed in latched and I left the underscore in front of LED, and of course the tag is latched LED no underscore. So I quickly removed that when I had the recording session paused. So if you noticed a little disconnect there, my apologies. No errors, that's a good thing. We're back in the run mode. Let's turn the watch window back on. And now we're going to operate the latched LED. So I'll drag this up so you can see the tags. The display enable switch is on, now it's off. So if you look at the second tag value, 0, 0, now it's 0, 1. So we turn on the display enable switch. Now we'll hit the start push button, and you notice that the timer timing LED comes on. At the end of 2 seconds, the latched LED comes on and stays on when I release the button. If I push the input associated with reset push button, then it resets. The only thing that stays on is the latch delay enable in. You see that's still on. The latch delay to enable in is set to 1 because by default for a function block diagram timer data type, it's set to 1 unless you add a tag, an input reference that is 0. In other words, if you clear it, then the timer won't function unless the enable in is set to 1. However, by default, it's automatically set to 1 unless you do otherwise. That's why that bit stays on all the time. So see, now we're set back to 0. If I push the start push button, you'll see that the start LED did not come on, and the latched LED does come on. When I let go of the button, hit the reset. So this logic behaves 100% identical to our ladder logic diagram. And it's a little short on code compared to what you had, because remember, we left out the code that was redundant to this line right here of our first little section of code. Well, that wraps it up for structured text. I know this wasn't terribly exciting, and I can't imagine anyone doing this type of logic or this type of control with structured text, because this code is much more difficult to construct than this code. If you think about the amount of time it took to configure this code in ladder logic, because remember, there's no constructs or logical operators explicitly shown here. So this really, the beginning of this rung says if start push button, then enable in the timer, and if display enable switch, then turn on this bit, and if timer timing, then turn on this bit. Down here you have if latch delay is done, or latched LED and not reset push button, then latched LED. We go back to our structured text. You see, if latch delay 2 or latched LED and not reset push button, then latched LED. So this is the exact same code as far as the machine's concerned, just not as far as you're concerned. In one of our more advanced volumes, we will do some structured text with a more legitimate application.